Hello friends, welcome to a new video of Python series. In the previous video, we have learned different kind of operators in Python. We have two more operators in Python, such as identity operators and the bitwise operators. I could have discussed these two operators in the previous video, but I didn't because the previous video was getting too long. Okay, no problem, we will learn these things through this video. Then let's get started. Hello friends, this is AK and you are watching Stack Bounty YouTube channel. Let's talk about Python identity operators. First of all, let me create two variables like a equals 5, b equals 5. In identity operators, we have is and is not. Well, if there is someone who has come to this channel for the first time, I would like to suggest them to start watching the videos from the beginning of this playlist. Actually, this is the 8th video of this Python series. If you want to access full playlist of this Python series, then check out the description box of this video. I have put the link of Python playlist there. And if you are getting any benefits from this video, so like these videos and also subscribe to this channel for coding related things. Okay, let's come back to our main topic. Identity operators compare the memory location of two objects. As I said earlier, in identity operators we have is and is not. Now let me create a print statement like print A is B. See, in our case we have assigned 5 to each of them A and B, and here our is operator will return true if the variables on the either side of the operator point to the same object. In Python we identify same objects through their identity inside memory. When we store a value inside a variable, then the value will be stored in a specific address inside our memory, right? The position of each value is already allocated in our memory. In our case, we have stored 5 in two different variables, but their identity will be same. Okay, let's check. We are going to check the identity of 5 by using a special kind of function, that is id. I am using id function 2 times because I want to check both of them. Inside the id function, we have to pass the variable name. For the first one, a, and for the second one, b. These two id function will return the identities of these two variable a and b, but the returning value will be not visible to us. To print the value, we wrap this by print function like this: print id of a, print id of b. Okay, let me comment out this print statement. Now click on the run button. As shown, the first one is the id of a variable and the second one is the id of b variable. There are no difference between these two IDs, right? Now overall the thing is, if we are storing same value in different variables, then their IDs must be same. Now let me clear id functions. Now we will perform our execution by using is operator like this. As I said earlier, in identity operators, is operator returns true if the variable on either side of operator point to the same object. In our case, 5 is stored into two different variables, so it will definitely return true because they are allocated same ID inside our memory. Okay, let's print. If I click on the run button, see the output. It prints true. Now if I change the value inside our b variable like 4, tell me what it will print. Any guess? Definitely false because they are not point to the same object. Now if I click on the run button, see the output. It returns false. Now let's talk about is not identity operator. Now we will put here not keyword after is keyword. Is not operator returns true if the variables on either side of the operator not point to the same object. Otherwise, it will return false. Now have a look at our expression. Actually, a and b not point to the same object because inside a variable we have 5 and 4 inside our b variable. So they are completely different to each other, right? So our is not operator will return true. Okay, now if I click on the run button, see, it returns true. If I change 4 to 5 inside our b variable, now see the output. It says false because they are same. Now let's move forward to the bitwise operators. Okay, first of all, let me create two variables like x equals 10 and y equals 12. You know, bitwise operator works on bits and performs bit by bit operation. Now the question arises, what is bit? If you are from computer science background, you often heard about bit and byte. Okay, let me define two of them in short. You know, in our computer science, we have only true and false, and we have to represent everything in the form of zeros and ones. For that, we can convert our decimal digits to binary. Here, 0 refers false and 1 refers true. You know, a bit is a basic unit of information or is the smallest unit of data in the computer and digital communications, which stands for binary digit. Either 1 or a 0 is used to represent each bit, and a byte is made up of 8 bits. If you have 2 bytes, definitely it would be 2 into 8 equals 16 bits, right? Let's have a look on our variables. See, here we have 10 and 12 stored inside our x and y variable. As I said earlier that bitwise operator works on bits, but in our case 10 and 12 are decimal values. We have to convert them into binary format. If I convert 10 and 12 into binary, the result will be like for 10, 1010, and for 12, 1100. But how? You know, you are a programmer. You must have a cool personality. You need to know every logic before performing any execution in virtual world. You know, the binary number system has a base of 2 because it has only 2 digits like 0 and 1 to represent any number. Similarly, the decimal number system has base of 10 because it has 10 digits to represent a number like 0, 1, 2, 3, 4, so on to 9, right? Well, here 10 and 12 decimal number. Now let me show you how to convert 10 to binary. Okay, first of all, divide 10 by 2. If I divide 10 by 2 like this, here remainder is 0 as shown, and the remainder will be placed on here, and 5 is our obtained quotient. Now divide the obtained quotient by 2. We have to divide 5 by 2 like this. Now we get 1 as remainder and obtained quotient is 2 here, and we have to repeat these steps until we get 1 at the end. Now we have to divide 2 by 2 like this. Done. So here we get 1 at the end and we have 0 as remainder. Now all you have to do is now note down all the remainders including the last one like 0, 1, 0, 1. Now reverse the order of this. If I reverse the order, it looks like this 1, 0, 1, 0. Done. And that is the binary format of decimal number 10. And you will get the binary value of 12 applying the same process. I am not doing it manually because it's just so simple, you know. For now, I think you don't need too much these things like binary conversion, bit, byte. When you will learn data structure and algorithms, there you will learn these things in detail. Okay. Now we have binary values of 10 and 12. Now we can perform operations with bitwise operators. In bitwise operator, we have bitwise AND, bitwise OR, bitwise XOR, bitwise ones complement, bitwise left shift, bitwise right shift. Now let's perform bitwise AND operation. Now type X and Y, and that symbol called ampersand, that is represent AND operation, right? Now what it means by this expression X and Y? If you remember, we performed certain operations while we were learning logical operators. There we used AND keyword, but in bitwise operator we use ampersand symbol like this. In logical operator, we are getting true or false as output, but in the case of bitwise operator, it always returns the result in decimal format. Okay, now I am wrapping it by print function so that the result will be visible to our output screen like print X and Y. Now have a look at our print statement. Here we are performing AND operation between X and Y. Now I am sharing a truth table of AND operator. Actually, in the truth table we have only 0 and 1. As I said earlier that 1 equals true and 0 equals false. Now I am representing a sequence format of our binary values of 10 and 12 for calculation purposes. Have a look at our expression. We say x and y. Here x comes first, so its binary value is placed above y. Okay, here let me clear one thing, that is, if there is someone who has not seen operators video of my Python series, believe me, the operations I am going to perform by using bitwise operators, you will be not able to understand whole thing. Well, let's come back to our main topic. If you remember, while we were performing logical AND operation in the previous video, I said there that the logical AND operator returns true if both expressions are true, otherwise it will return false. Now have a look at our binary sequence format of x and y. Here 0 equals false and 1 equals true, right? If we take first one from right side, both of them, there are 0 and 0. Means false and false. As we know, if both of them false, our AND operation will return false, right? And as we know, false equals 0, so we can assign here 0. Next, we have 1 and 0, means true and false. Here we also get false, means 0. Also you can follow the AND operator's truth table. I am assigning here 0. Okay. Next we have 0 and 1. Also we get 0, so I am assigning here 0. At last we have 1 and 1, means true and true. So our AND operator returns true here, means 1. So I am assigning here 1. So overall we are getting 1 and 3 times 0 by performing AND operation. And if I convert this binary value to decimal value, like 0 into 2 to the power 0 plus 0 into 2 to the power 1 plus 0 into 2 to the power 2 plus 1 into 2 to the power 3 equals 8. Definitely 8 comes out from this binary value. That was the process to convert binary to decimal. So here we have done AND operation by doing manually and we get 8 as a result. Now we will run our program to get the result of our AND operation between x and y. So if I click on the run button, see the output. It prints 8j. So overall the thing is, if we perform bitwise operator between 10 and 12, we will get 8 as a result, right? Now let's talk about bitwise OR operator. In bitwise OR operator, we use OR symbol. So I have to put vertical bar symbol in between x and y, like this. Now let me clear the two things, the result of AND operation and the truth table of the AND operation. Now I am sharing the truth table of OR operators. If you remember, while we were performing OR operations in our previous video, there the logical OR operator returns true if our expression is true and it returns false if both of them are false. Now have a look at our binary format sequence of x and y. From the right side we have 0, 0. As we know, in this case our OR operator returns false, means 0. So I am putting here 0. Next one is 1, 0. Here OR operator will return true, means 1. So I am putting here 1. After that we have 0, 1. Here OR operator returns true. Also we are getting 1. So I have to put here 1. At last we have 1, 1, means true and true. So we will get true, means 1. So I am putting here 1. Done. If I convert this binary value in decimal, we will get like equals 14. Now we will perform this OR operation by using our Python code that is already we have. Now if I click on the run button, see the output. It says 14. Now let's move forward to our next bitwise operator, that is XOR. It's also known as exclusive OR operation. Now let me represent the truth table of XOR operator. Now let me put caps symbol between x and y. This cap symbol represents XOR operation. In XOR operation, if you have different number, you will get 1, otherwise 0. Here, according to our truth table, 1, 1 is 0 because they are same. 1, 0 is 1 because they are different. 0, 1 is also 1 because they are different also. 0 0 is 0 because they are same. In short, you will get 1 only when both of them are different to each other. If same, you will get 0. Now have a look at our binary sequence format of x and y. Here, from the first we have 0 0, so that is 0. Next 1 0, that is 1 because they are different to each other. Next we have 0 1, that is also 1. At last we have 1 1, that is 0 because they are same. So we get 0 1 1 0. If I convert this binary value to decimal, it will become 6. So we have 6 as a result. Okay, let's perform by our Python code. If I click on the run button, see the output, it prints 6. So if we perform exclusive OR operation between 10 and 12, then it will return 6 as a result. Now let's talk about bitwise ones complement. Let me clear my screen. Create a new variable like a equals 7. You know, in complement bitwise operator, we use tilde symbol like this. You can find this symbol below your escape key on your keyboard. This symbol represents complement bitwise operator. You know, once complement operation invert each bit of binary value and returns the bitwise negation of a value as a result. If I convert 7, that becomes like 5 times 0 and 3 times 1. Once complement revert the binary format. If I reverse the binary format like 1 for 0, 1 for 0, 1 for 0, 0 for 1, 0 for 1, 0 for 1, 0 for 1 and 0 for 1, like 5 times 1 and 3 times 0, like this. If I convert this binary sequence into decimal, it will be -8. Let's see by doing execute our program. If I click on the run button, see the output, it says -8. Actually, it's basically used to store negative values in Python. Right? Now let's talk about left shift bitwise operator. Let me create a variable like b equals 2. I am putting an expression inside my print function like this, and that symbol refers here left shift operator. Now what do you think? What will be the output if I click on the run button? Any guess? Let's see. It's quite weird. It says 28. Let's have a look at our expression that is inside our print function, left shift operator. What it will do actually, the left operand's value will be moved left by the number of bits specified by the right operand. In our case, the binary format of 7 will be moved left by the 2 bits. Let's understand with the diagram. So here we have the binary format of 7, that is 5 times 0, 3 times 1. For now, forget the all zeros. Now we have only 3 times 1. And imagine there is a point after the ones, and assume 3 times 0 after point like this, 111.000. In our expression, we said to move 2 bits to the left hand side. According to our expression, we have to shift 2 zeros on left. Now it looks like 111.00.0. Now forget about the point and the last 0. Now we have only 3 times 1, 2 times 0, means 11100. If I convert this into decimal, we will definitely get 28. One more we have, that is right shift. First of all, let me put the right shift sign like this. This symbol refers to the right shift operator. Now we say to shift 2 bits to right side. As before, we will put a dot after ones and 3 zeros after the dot like this, 111.000. Now we have to shift 2 items from our binary sequence of 7. Okay, let me do this. As earlier, we will forget dot and all the items after dot. Actually, zeros are not important if they are after point, right? Now we have only 1. If I convert into decimal, that will be 1. Okay, that's all about for today. Then see you on the next video. Have a good time. Goodbye.